In this PowerPoint, I'm going to show you guys how to predict the products of chemical reactions. Yesterday, we talked a little bit about what each chemical reaction is, what the types are, and what you're going to see now is how do we figure out what products are produced from them. So here, as a review, you can see some different types of chemical reactions. You will see a double displacement on top. Your sodium nitrate and your lead 2 oxide is producing lead 2 nitrate and sodium oxide. You'll notice that the cations, sodium and lead, are swapped in the products. So that's what happens during a double displacement or double replacement. It can be named both things. In a combustion reaction, you have a hydrocarbon. You'll notice carbon and hydrogen together. You also have oxygen here, but carbon and hydrogen are forming a compound here, a hydrocarbon, plus your oxygen yields carbon dioxide and water, and that's a combustion reaction. In the next one, you also have another double replacement or double displacement reaction where you have zinc and lithium swapping places to form new compounds. They just switched spots. They switched cations and anions. The next one is the same. And then you also have a synthesis reaction where you have sulfur plus oxygen yielding sulfur dioxide. So that's synthesis or combination. So those are just a few different types of reactions. And we've seen others as well. Now here, what we're going to talk about is how do we organize our information and figure out what we're trying to do. Now, first of all, when we're having a chemical reaction, we have to do a couple things. Number one, we form chemical equations or balanced equations. We're not going to balance quite yet. We're going to balance next week. But if you go this way to the balanced equation side, you can figure out, what is my balanced equation? What are my products and reactants? On this side, you are just kind of naming your different types of reactions. So we've done that, but now we have to figure out what are the products. Again, we're not going to balance the equations yet, so we're going to skip that for now. When we predict the products, we're going to really focus on three types. We're going to focus on combustion, single replacement or displacement, and double replacement or displacement. Synthesis and decomposition aren't as simple, so we're going to focus on these three. Now in combustion, remember I told you that your products are always going to be carbon dioxide and water. That is going to be something you'll always have to remember. So here are some rules. First of all, when you are forming your products, you absolutely have to create neutral ionic compounds. You cannot just create compounds that are not, neutral. You have to swap and drop. So when we learned about how to make ionic compound formulas, you're using this again. Okay, so you're going to create your ionic compounds. Make sure you pay attention to charges and swap and drop. In your compound, please remember that you never include your charges in your compound because the compound is neutral. You do not carry any subscripts from your reactants to your products. For example, if you have something like sodium chloride and magnesium bromide, NaCl is sodium chloride. You have ones for your subscripts. Magnesium bromide is MgBr2. You have a 2 there right after the Br. Your products are going to be NaBr and MgCl2. Notice how the subscripts are going to change. So please be aware of that. You have to create brand new formulas in your product side. You always balance your equation last. And again, we're not going to do that quite yet. We'll do that when I return. So here's your combustion reactions. And honestly, these are the easiest ones you can do. You're always going to have a hydrocarbon or a carbon-hydrogen combination plus oxygen. That will tell you right off the bat, this is a combustion reaction. Your products are always going to be water and carbon dioxide. Do not worry about balancing yet. Just take a look at these examples. You have CH4 plus O2 yielding CO2 plus H2O. Hydrocarbon plus oxygen is carbon dioxide and water. Again, below that, you have C4H10, another hydrocarbon, just a different one, plus oxygen yielding carbon dioxide and water. in this next slide, we have single replacement reactions. Now, when we do a single replacement or a displacement reaction, we have to look at something called an activity series chart. Now, you'll look on the side here, you will see this activity series chart from most to least active. The metal is always going to, if there's a metal in the compound combined with a single metal by itself, you have to figure out, is the metal going to replace, the metal by itself going to replace the metal in the compound? If not, then there is no reaction. You're going to use your activity series for this. So on this activity series, find something like aluminum. Aluminum is here. Can you see my arrow? And if you have aluminum, if you have a compound that has calcium in it, aluminum is below calcium, which means that it cannot kick calcium out of its compound. Therefore, there's no reaction. But if calcium is by itself and aluminum is in compound, calcium can kick aluminum out because it is higher on the activity series than aluminum is. You can also do the same for the halogens. If you have a compound, for example, sodium bromide, and you combine it with iodine, iodine is not going to kick out bromine from sodium bromide because it's below bromine in the activity series. What has to happen is bromine would have to be alone, and you'd have to have something like sodium iodide, and bromine therefore can kick out iodine. And we'll see this happening in examples. So here are your single replacement reactions. When you're predicting products, you're going to replace the single element, the element that stands alone, with the corresponding element in the compound. That means that if you have a cation or a metal standing alone by itself, that is what you're going to replace with the metal in the compound. If you have an anion standing alone, you're going to replace that with the anion in the compound. If the element by itself, the standalone element, is more reactive than the one it is trying to replace, then it will happen. If it is not more reactive or it becomes below on the activity series, then it will not kick out the element and therefore there will be no reaction. So here's an example. Here you have magnesium plus aluminum chloride yielding aluminum plus magnesium chloride. Now what we have to see is this. Magnesium is by itself. Aluminum chloride is a compound. Magnesium would have to be above aluminum on the activity series, that chart I showed you, in order to switch places. Otherwise, no reaction happens. So when you look at the activity series, you can see that yes, magnesium is higher on the activity series than aluminum, and therefore will kick it out of compound. Okay, now if you switch them, if you put aluminum by itself and combine it with magnesium chloride, because aluminum is lower on the activity series, there is no reaction, and therefore you wouldn't have anything happening there. There'd be no reaction. It cannot replace it. All right, so that's what happens there, and this is the same one. So we will do some examples here. So iron and copper to chloride yielding iron to chloride and copper. Does that work? When we look at our activity series, we can find that iron is, let's see, down here, and copper is below it. That means iron can knock it out, and therefore there is a reaction. The next one, zinc plus nitric acid, is yielding zinc nitrate plus hydrogen. So when we look at this, we can see that, we're looking at zinc and hydrogen. Hydrogen is way down here. Zinc is way up here. Zinc can knock hydrogen out, and therefore there's a reaction. But in the next one, magnesium chloride and bromine. Here you're going to look at chlorine and bromine and say, can bromine knock out chlorine? These are both anions, so you have to think of the anions together. Magnesium doesn't matter here. So is bromine higher than chlorine? Nope. Bromine is right below chlorine in the halogens, so therefore it cannot replace chlorine. Now if we have double replacement reactions, All we're doing here is that the cation and anion are switching places. So you have to create brand new compounds. Don't just, bring over your subscripts. That doesn't work. So you're gonna do a swap and drop of compounds, and you can see here what's happening. You have calcium hydroxide plus hydrochloric acid, or hydrogen chloride, if you want to say that, and they're going to swap, and you're going to give hydrogen the hydroxide and calcium the chloride. In this case, you have to remember that both compounds are ionic compounds. They must be ionic compounds. You're going to separate each compound and write their charges. You're going to swap and you're going to switch the spots, switch the cations, write new compounds, and swap and drop. So here, lead 2 nitrate plus potassium iodide. You're going to take your lead and your nitrate and your potassium and your iodide. You're going to swap them, and you're going to swap and drop the charges so that you have lead 2 iodide and potassium nitrate. Don't worry about balancing. We're not balancing. See this? You're not doing that. Not yet. Now, we're not going to worry about this, but you should know that not all of these reactions are going to occur. We're not going to do solubility tables right now. We'll do solubility much later. Okay, so don't worry about solubility. We won't do that. We'll stop right here. And your homework tonight is going to be to try to figure out some of these products for reactions. So make sure you take a look at that and do your best. You can look at this again, and that way, hopefully you'll understand how to predict products, and we'll go over it on Monday.